I want to start out class by making some announcements and showing you various things. Okay, I sent an email to the class on Thursday. We had class on Friday. But just as an update, so nothing is a surprise to anybody, test 1 is on Friday. My pen is running out of ink. Oh, that's the old one. Test 1 is on Friday. Okay. Again, I announced that last Friday in class. According to our syllabus, it's supposed to be on Wednesday, but I'd like to give us a little more time. Okay. So essentially, for our class this week, today, we finished 1.5, didn't we? Friday. Yeah, we finished 1.5 on Friday. So today I'll talk about 1.6. Wednesday, I'll talk about 1.6, and I'll also talk about your test, tell you what to focus on, et cetera, et cetera. And then Friday, you'll take your test. Okay. What I want to mention first and foremost is for your test, you're going to want to have a calculator. And the calculators that we let you check out for the semester for free down in the library that I've been talking about, if you haven't checked one out, go for it, it's free. But they can be checked out from the Missoula College Library, not UM's library, the Missoula College Library has them. Okay, you're going to want to bring a calculator and a pencil. I always recommend doing tests in pencils. You can do it in pen if you want to, but I tend to recommend pencils in case you make a mistake and have to scratch something out. Okay, optional, you can bring a sheet of paper with notes. It can be a regular size piece of paper. I don't care if you write on one side or both sides. It's your call. You know you are ready for a test when you don't need to look at this at all. Okay. But in case you do, you're going to be really happy that you have it there. Okay. So if you have to look at your sheet of paper with notes for every problem on the test, I would say that you're not as prepared for the test as you should be, but thank goodness you have that sheet of paper. Okay. Now, the reason why I allow a sheet of paper is, well, there's multiple reasons. Number one, in practice in life, we don't always have to memorize things. We just need to know when and how to do them and use them. My hope, though, is that with the amount of practice that you're getting in the class, that you are going to remember these things, whether you really wanted to or not. But the whole idea is that while you're preparing for the test, if you make this sheet of paper, a lot of learning happens as you're going through the material and being like, what do I have a handle on and what don't I have a handle on? Okay. So what I will say in terms of open homework, section 1.4 is due tonight by midnight. Section 1.5 is due next Monday, and section 1.6 I'll have due next Wednesday. Now, notice these are due after you're going to be taking the test. Okay, I do that because I promised you on day 1 that I would give you all 1 week from the day we finish a class section for you to complete the assignment. I strongly, strongly, strongly suggest you get these done by Friday, test day, because the practice will sure be helpful. Okay. So again, I give you a week because I promised that, but my strong suggestion is do this by test day. That's my strong suggestion. I'll discuss your test in more detail on Wednesday. Okay, so this is really important. Anyone in this class who uses ODE to take their test because you get extra time for whatever reason, you got to get me that thing like now, okay? The accommodation form, because they need to reserve a room for you. Those of you who do this class remotely, in other words, on Zoom or listen to a recording, you must contact me like today if you can't make it for this test time, okay? You still have to take the test on Friday. We're just going to have to find a time that we can Zoom. And you're going to have your camera on, and it's timed just like everyone else's test, but you have to have your camera on your work and all of that stuff. So ideally, those of you who Zoom can come here on Friday to take the test. If you can't, you need to email me like ASAP so that we can schedule a mutually convenient time for either you to come into Missoula College to take it if you want to take it live, or for us to Zoom and for me to watch you take it on Zoom, okay? But this is the ideal, that you just come. Next thing, I want to show you 2 items. If you look at our class Moodle page and you go to class activities and projects, you'll see that I've posted a test 1 review as well as solutions. Okay, what I'm going to tell you about the test 1 review, this is not for a grade. I strongly recommend you do it, and I strongly recommend you don't look at the solutions before you actually do the test, because unfortunately, you're not going to have the solutions on the test before you do it. But this test 1 review on Moodle is there for you to get extra practice. But what I will say is do all except the second part of number 1E. I asked you to find an equation of a line there, and we hadn't gotten there yet, but I snagged that problem from an old final exam that I gave, and it's a really great question other than one part of one of the parts jumped ahead. Okay. The other thing that I want to show you that's available to you, if you want it, is as follows. If you go to our class, My Open Math page, and you go to chapter 1 and you go to the bottom, there's a test 1 review that's also available on My Open Math. Okay, this is just like the other test review. It's not required. I just like to give you a lot of opportunities for practice. Don't worry, it is not linked to the grade book, so this will not affect your grade. Okay, but I love to give people as many opportunities for practice as I'm able. Cool? Ish. All right. So, you ready? Okay. What I want to do, this is a fun section. I'm just telling you, section 1.6, inverse functions. All right. So if my function is to take a step to the right, what would my inverse function be? Wouldn't that be to kind of undo it, take a step to the left and get back to where I started? if my function, my sole purpose, haha, I was talking about putting on my shoe, get it, soul. Anyway, sorry, stupid joke. If my function is to put my shoe on, wouldn't my inverse function to be to take my shoe off? Okay, so when we talk about inverse functions, essentially what we're trying to do is undo the original function. Okay, so for example, I'm just going to make up some cute little function f, and f takes 1 to 3, it takes 2 to 4, oops, and it takes 3 to 5. What a fun little function this is. Could I write these as ordered pairs? Yeah, how would I write this one as an ordered pair? 1, 3, 2, 4, and 3, 5. Okay. The notation for the inverse of a function is you write it as f to the -1 power. Okay. So if my function takes 1 to 3, what would the inverse do? Wouldn't it take 3 and bring me back to 1? Right? It's undoing my original function, taking me back to where I started. If my function takes 2 to 4, what would my inverse do? 4 back to 2. If my function takes 3 to 5, what would my inverse do? Wouldn't it take 5 back to 3? Okay. I could write each of these as ordered pairs. Wouldn't this be 3, 1, 4, 2, and 5, 3? What happened to my corresponding ordered pairs? Yeah, they flipped or they bebopped, right? So if AB was an ordered pair on my function f, wouldn't BA be my corresponding ordered pair for my inverse? Okay. So using this up here, if I take 1 and plug that into my function f, 3 is going to come out. And notice my inverse takes 3 back to 1. You with me this far? Okay. Just want to get back to where we started. Like not a real life thing. So what if I tell you this is a new function? If f of 5 is equal to 9, what is f inverse of 9? Sure is. Okay, let me show you a little picture. F of 5 equals 9 means that my function f takes 5 to 9. By definition, if I have an inverse function, wouldn't this just go the other way? And aren't we saying, hey, what happens when you plug 9 into your inverse function? And the answer would be 5. Oh, smile. You with me here? Okay, this looks a little funky, but check this out. Suppose I tell you when I plug 3 into my inverse function, -7 comes out. What is my function value at -7? Yes. Okay, what have I shown here? Well, I tend to draw my inverse going this way. Aren't we saying when we plug 3 in our inverse, we get -7? And then the question is, well, where does the function take -7? And our answer is 3. You might ask, why are you doing this? And my answer is because I want you to get used to the notation. Okay, remember what it means on how we write when we plug things into functions. So what I can say is, in general, do you agree that the inputs for my function are my domain? Do you agree my function f goes from my domain over to my range? Right? Inputs, outputs, just the fancy names. Do you agree that my inverse goes the other way? So isn't this stuff the inputs for my inverse? So this is the domain of my inverse. And then these are the outputs for my inverse. In other words, these are the range of my inverse. So the moral of the story is the domain of your function is the same as the range of the inverse, right? What you plug into one function is what comes out for the other one. And the range of your function is the same as the domain of the inverse. So let's talk about this. Suppose I take x and I plug it into my function f. Can you tell me what does the output look like? How would we write it at this point? Wouldn't we just write that as f of x? What happens when I take that output and plug it into my inverse function? Where do I have to get back to? Where I started. In other words, I'm taking x, I plug it in, f of x, and out comes f of x. And then I take this and plug it in my inverse. And we get back to where we started. Now I want to relate this to something that we did in section 1.4. I'm starting with a value of x. I plug it into my function f, and f of x comes out. Okay. Now, what do I do with whatever the heck this is? Don't I plug that into my inverse function? And I get back to where I started. So what this tells us is a way to verify whether or not two functions are inverses of each other. And is also the reason why we talked about composition of functions. So to verify two functions are inverses of each other, and I'll call those two functions f and g, it means you do the composition both ways, and whatever you start with is what you end with. I won't ask you on a test to verify that two functions are inverses, but I am going to go through a couple of examples because section 1.4 online homework is due tonight by midnight, and it's all about composition. So you may as well get some practice. So suppose I tell you f of x is x cubed minus 5. And g of x is the cube root of x plus 5. Verify that these are inverses. Can we do it? Yeah. Okay. First, let's do f of g of x. Can someone tell me, how do I start the composition here? Okay, first I write however my g of x is defined, don't I? Remember we were playing with the compositions in general last week? So g of x in this particular example is defined to be the cube root of x cubed plus 5. What does it mean to find my function value at this yuck? It means that everywhere where we see an x in our function, we're going to plug that in. So in place of x here, I'll write the cube root of x plus 5. Notice my x value is cubed, and then I have minus 5. What happens to my cube root and my cube? They cancel out, right? Because the cube root is the 1/3 power, and 1/3 times 3 is 1. So we're left with x plus 5 here, and then we got the minus 5. So don't we just end up with x? Isn't that cute? Let's go the other way. Now I want to find g of f of x. Well, what do? I start out by putting f of x, however it's defined, in my parentheses, because now I get to plug that into g. So it's the cube root. In place of x, I put this x cubed minus 5, and now I got plus 5. Do you agree the 5s cancel and I'm left with the cube root of x cubed? And what's that equal to? X. Isn't that so cool? Relatively speaking. Any questions this far? All right. Now, this is not on your test, but this is something that I want to mention. Do you remember at the beginning we talked about one-to-one functions? Okay, recall that we have a function if each x value goes to exactly one y value. Remember that? That was our vertical line test. Recall that a function is one-to-one if each y value is hit by only one x value. And you may or may not recall that was our horizontal line test. I'm not asking you if things are one-to-one on the test. Okay. Well, my favorite function that's not one-to-one is y equals x squared. You agree it's a function, it passes my vertical line test, but it doesn't pass my horizontal line test. Well, let's ask ourselves, what would the inverse look like? I'm just going to take a couple things. If I have y equals x squared, if I plug 2 into my function, what comes out? 4. So if I had an inverse here, what would the corresponding ordered pair look like? 4, 2. Right? You just bebop the ordered pairs. What if I took -2 and plugged it into this function here? Wouldn't 4 come out? So if I had an inverse, what would be the corresponding ordered pair over here? 4, -2. Oh no! What's the problem here? I got an input going to more than one output. This one is not a function. So this is the reason why we talk about one-to-one functions, okay? Only one-to-one functions have inverses. Now we have a way to get around that. It's nothing we're going to do in this class, but is anyone going on and taking trigonometry? Okay, you're going to really have to hone in on it there because our trig functions are not one-to-one, but boy, oh boy, do we love our inverse trig functions. Okay, what we tend to do is if you have a function that's not one-to-one, and we're not doing that in this class, but I can't leave you with a cliffhanger for a whole semester, is we tend to just consider part of the domain. So in other words, I can just consider my x greater than or equal to 0. And now I can talk about the inverse. And the inverse in that case would be the square root of x. I think you'll grant me that the square root undoes squaring. Okay, we're not going to go there in this class, but this is why we talked about one-to-one. And this is also why we've done composition of functions. Okay. Now, what you will have to do on the test is, assuming we have a one-to-one function, how do we find the inverse? You will have to do this on the test on Friday. Okay. I won't ask you to find the inverse of a function that's not one-to-one to begin with. I'm just not that sort of person. Okay. So what I'm going to do is show you the steps. You rewrite f of x as y, assuming that your function originally was written y equals blah, blah, blah. The next step is you switch your x and your y. These two steps are kind of non-steps. I call them non-steps because they're really not really doing much. This third step is where difficulties can arise, okay? Not for us right now. You solve the resulting equation for y. This is the math step, okay? And you're going to see that it's not even always possible when we get to exponential functions, even though we know they're one-to-one and the inverse exists. And finally, you replace y with writing it as the inverse. And be sure you are writing the inverse using appropriate variables. All right. Ready? Suppose I have f of x is equal to 2x minus 5. Find the equation of the inverse. Okay. What does my first step tell me to do? Yep. I'll write that as y equals 2x minus 5. What is my second step? Switch x and y. In other words, very literally, where you see a y, put an x, and where you see an x, put a y. It's kind of why I said they're non-steps. Okay. Now comes the math that we have to do. My third step is to solve for y. In other words, I want to get y all by his lonesome over here. Okay. What would be my first step in order to get y alone here? We would first add 5 to both sides, right on.
5 by 2.
So we get x plus 5 is equal to 2y. And now we divide both sides by 2. So I get y is equal to x plus 5 over 2. Now, I claim we could also write that as 1/2 x plus 5/2. I don't care which way you write it. Okay, so my inverse function is, and again, who cares how we write it? What do you want me to write? 1 or 2? 2? Okay. There we are. I claim this is the inverse of that. Now, here's the cool thing. You don't need me to grade a darn thing. You know why? You can check your own work here. Couldn't we verify that these are inverses if we really felt like it? How would we do that? Composition of functions. Does anyone want to see me do that? We got a yes? Okay. So what I'm going to do is verify that these are inverses. So I'm going to put F on the outside. So wouldn't I write that's F of 1/2 x plus 5/2? I just rewrote my inverse inside. What does it mean to do that? It means everywhere where we see an x in our function f, we get to plug this yucky stuff in. Any questions this far? Well, what do I do with my 2 now? I distribute. What's 2 times 1/2 x? X, right? My 2's cancel. What is 2 times 5/2? You with me? And then I got -5, and lo and behold, Shazam. Isn't that fun? Do you want me to go the other way? Or do you see it? What do you want from me?
Will this composition here be on the test?
Well, you need to know how to do compositions. I won't ask you to verify it, but I do ask you to do composition of functions on the test. Would it be helpful for me to go the other way? Okay, so let's do F inverse of f of x. Well, what I do is I start inside and I say, oh, f of x in this specific example was found to be, or given to be 2x minus 5. What does it mean to find f inverse of a yucky looking thing? It means that you plug this yucky looking thing in for x. So do you agree that would look like 1/2? And then in place of x, I put 2x minus 5. And then I have plus 5/2. Well, next thing I'll do is distribute my 1/2. What is 1/2 times 2x? What happens to these 2's? They cancel, numerator, denominator, see you later. And 1/2 times -5 is -5/2. Then I got this +5/2 hanging out. Isn't that cute? All right. What if I have y is equal to the cube root of x minus 7? What if I want us to find the inverse here? Well, step 1 was replace f of x with y. We don't have to deal with that. So what's my first step in practice here? Good job. Switch my x and y. And now we've got to solve for y. Oh my goodness, it's stuck under a radical. Stuck under a cube root. How do we get rid of this cube root? How do you get rid of the 1/3 power? You cube both sides. I think that's what you were saying, Kiki. Yeah. Okay. Do you agree I can cube both sides? Well, if I do that, I get x cubed on my left, and I'm able to break out of my radical on my right. Aren't I left with y minus 7? And what's my last step to get y alone? Add 7 to both sides. I claim these two are inverses of each other. I have 2 more examples that I want to do. Cool. Questions here? Okay. This is a fun one. What if I get y equals 4 minus x? Suppose this is my function and I want us to find the inverse. We'll do this one together, and then I'm going to write one down and have you work on it on your own, and then we'll go through it. What would be my first step in order to find my inverse function here? First, what do I need to do? Don't I need to switch x and y? Okay. Now you're right. In order to get y alone, I'm going to subtract 4 from both sides. Do you agree I get x minus 4 is equal to negative y? But I don't want negative y. I want positive y. How do I get rid of the negative? Yep, we can think of it as multiply or divide everybody by -1. If I do that, doesn't that just change the sign of everybody here? So I get negative x plus 4 equals y. What do you see in this case about the function and its inverse? Couldn't I rewrite this as 4 minus x? They're the same. Funky stuff going on. All right. Find the inverse of this one. I want to give everyone a few minutes to look at it, to work through it, and then we'll go through it. Give me a thumbs up when you're ready. Wow, you're all really fast. Okay, tell me what to do. Switch them. Now what? Add 11. Divide by 2. Done. Or you can write it as 1/2 x plus 11/2. Cool. Wow. Okay. So we still technically have 7 minutes left in class and we're done. I guess this is why we could have had the test on Wednesday, but here's what I'm going to tell you all to do. Not that I like telling people what to do, but this is my strong suggestion. Okay. So first off, this finishes the material for the test. When I talk about My Open Math, I usually like to call it MOM, My Open Math, just because this is easier to write. And yay, Mom. Okay. So on the My Open Math, there's that test 1 review. On Moodle, there's a test 1 review. My suggestion for you is that between class now and on Wednesday, first off, you wrap up your homework in 1.4 through 1.6 on MOM, but also work on these test reviews and I'll answer any questions and clarify anything. So Wednesday is a total question day and a great way for you to prepare for your test. So I suggest you work on these things. And if you have online homework questions in 1.4 through 1.6, I'll answer them on Wednesday. If you have questions on this test review, I'll answer those, or that test review. Sound good?
Cool. So Friday for sure.
Oh, heck yeah. Friday for sure for the test. Thanks. You're all awesome. I hope you have a great rest of your day.